Okay. Yes. Let me just. Are we seeing? Or have I shared? I'm not sure if I've shared this because. Yeah. So yesterday we stopped at analysis of one group, and that's what we ended our discussion. And Professor Cockton was saying something. I think I remember that was the last thing. So he was saying something about why did we not use peer this thing? You know, I will just show you because I was trying to demonstrate the reason. I myself, when I was looking for, how to run it with you, you won't see those statistics there, but you get to know where you can find them. This software, they improve because not all that's why they're having newer version every time, improving the version because when they develop it also, it didn't incorporate everything. So when we have some advancement and users begin to give question, why this, they keep on adding something. And some of the features, when they add it, you may see that it may not fall into where you expect it to fall into. Let me just, because I just remember that, and it's good to trash it out because I don't want any leave any stone unturned. I think this is the data set. Let me see if I can share it. This is the data set. I think it's this. No, it's not this. Let me just share that data set and just explain. Okay, this. No. Well, over too many things here. Let me see. Yeah. Yes, this is it. I think you can see now this is the median and the mark. It's only that I put the median back into the first one. Now, if you go to the analysis we did yesterday, analyze non-parametric data. If you go to one sample, is it one sample KS? Let's say we click. You see normal, uniform, Poisson, exponential. There is no the sign test, the Wilkinson you want to do. It's not there. It's not there. So the other way I was doing, I was trying to do is sometimes it give you funny because they say there are two ways you can do it. You can either do it the way we did it yesterday, or you come and now discover the yesterday. Yes. So instead of you can put ZESF. You click, can you see like there's a related sample before that one? You click on customize. When you click on customize, you click on feed. When you click on feed, you put mark. That's the feed. You now click on setting. You now click on customize here and see come to where is that space? Where it has it's not this one. And the sign Wilkinson, there is a place where you put where is this one? Okay, let me just run it now. Okay, just wait. There's option now. Okay, let's wait. On parametric. Okay, look at one sample here. Let's even one sample. Before you go down, without going to legal dialogue, if you say customize, yes, you now say, okay, I think I've done it. It's retaining the what is it? What I did is feed. Put the mark on the feed. test fit. I don't even know which. Okay. Yes, mark test fit setting. So that's 67, the median. After I click on this one and I put that 67 here. So let me share what it brought out.
The output.
Yes. So it just brought something out here. It just, so sometimes you cannot make meaning out of it. And that is why when you now go, how we did it is an option. That is the one people use. So
Dialogue.
yes, when you go to that the dialogue box, if you remember, I said that it's the same test you use for one sample and pair sample because the logic is the same. Yes. So when you now move both of them in. So what it's doing is that if you remember, how did you enter the median? You enter it as constant across all of them. So if the median you appear, if you look at it, when you are removing it also, what is the logic behind the pair sample is to remove one group for the other, right? When you remove it, even in a pair sample test, it will remove. The logic is to minus one from the other. So even in this one, in the sign rank, it's about minusing. When you minus and you are in this one now, the median you use it as a constant. So the median is serving as if it's the second variable now. Because across all of them, you put the median there. When you now put, can you see Wilkinson is there, sign is there. What you want to do. So it runs. It will even tell you, okay, mark more than median, less than median, mark that are less than median, mark that are greater than median. Because if you less than median and greater than median, bring the sign. Anyone that is less than median, when you remove, it give you positive. The one that is more than median, it give you negative. So you know, opposite direction. Look at this one now. The negative. If you look at this, okay, we are still coming back to explain. I will not talk about okay, just see that it's not significant, because when I now get to, that was why in the last one, what I did was that I just left that one sample to the, after I've done the pair sample, we did the independent sample, pair sample, and that came to explain it one time, because that one sample, you run it as if it's pair sample. I think we'll come back to it. Let's just note the result. It's not significant. Let's just discuss the other one. When we discuss it, it will be clearer. You know, if you look at it, the logic behind parametric test. Can we see my slide now? Can you see the slide?
No.
Because that's why I guess so.
No.
Don't worry.
No slide.
Don't worry. You can see the slide now. I share it. Can you see?
Yeah.
Respond if you can see. Can you see the slide?
Yes.
Okay, thanks.
Can see now.
Yes. Let's quickly look
data on substance use and depression.
Yes. Let's quickly look at the independent group now. This independent group, there are two groups. These two groups, just like the way we enter in Siri, look at this table. Though this table, this substance use is the same data set we're going to use to run independent sample and pair sample. You know, that is Wilkinson rank sum, which is independent. Wilkinson sign rank, which is independent pair. Rank sum just means that you rank them. You rank them from smallest to the highest. And the one you now select, you know there are two groups. You rank them irrespective of which group they belong. You know, you combine like this one and they are 10, 10, make it 20. If we rank them, we rank this 20 now. 10, the number 1 to 10 belong to drug. Number 11 to 20 belong to alcohol. This one is talking about substance use. We want to see the level of depression. It's only that we have 2 depression measure on Sunday and on Wednesday here. So they are separate variable. Depression, they measure on Sunday and on Wednesday. So these are the dependent variable, depression. The independent variable are the substance use that you think is causing depression. Substance, either drug or alcohol. Now, if you look at it, you can see it now. There are 2 perspectives. If you look at it as an independent group, 2 groups, you're having drug group and we have alcohol group. But if you want to look at it also as peer group, you have for both drug and alcohol, we have Sunday measurement, we have Wednesday measurement. Does it make sense? So 2 perspectives now on this data set. So we have independent, you can treat it as independent group, 2 groups, drug and alcohol. Drug and alcohol, look at their depression on Sunday, compare depression on Sunday between drug and alcohol. You can compare depression on Wednesday between drug and alcohol. Both of them, they are independent group. But if you want to also compare as dependent, you can say for drug, you're comparing drug depression on Sunday compared with Wednesday for drug, depression on Sunday compared with Wednesday for alcohol. So first of all, we want to look at the independent O now. The independent O is the one we call Wilkinson rank sum. What is that? It is not sign. Sign has to do with plus or minus. So for independent something, the plus or minus does not come because it is when you are removing some set of data from another one, you can be having plus or minus. Because some of the one you are removing from the other one, the one figure that are higher than what you are removing from will give you negative. The figure that are lower than that will give you positive. You get it? It is when you are minusing that you end up having 2 sets of signs. Some that are positive, some that are negative. That one is when you are doing with pair. The independent one, they are not removing anything. You just want to arrange it according ascending order. So let's just first of all consider the dependent one, independent one rather. So like I said, it's used for 2 independent groups. So the logic behind it is to rank it. When you rank it, so I don't like talking much. I want to go to where because all those things I put there, they are the thing I will explain here. So rather see it the way it is. Let me put this annotation. Look at it now. Look at the Wednesday. You know, they are separate variable, Wednesday and Sunday. But if you look at it now, they are 10-10 for drug and alcohol. I've arranged them horizontally. Can you see? So we now, if you look at it now, we now rank them we arrange them according to in ascending order. Look at it. 3, 5, 6, 6, 7, 8, 9, 10, 17, 24, 27, 28, 29, 30, 32, 35, 35, 36, 39. And there are 20 which are arranged in ascending order. Sorry. The same thing with this one also. We started with 13, 14, so we arrange it accordingly. But when you arrange it, you still have to note which, you know, you combine all the 2 samples together to arrange it. So here now is showing us which one we still want to know which group each of them belong to. So this one, A mean alcohol, B mean drug. So when you arrange it, you still have to tag it that, oh, this one, even though I put them, I just mix everything together, I still tag them to say this one belongs to alcohol, this one belongs to drug. But you arrange them according, it's just like if you go, maybe you have 2 schools that went for this thing, maybe for vocation. At the end of the night, okay, they should 2 schools. Now say everybody they should, okay, all the people in class 1 should be coming. In class 1, either for any group, irrespective of the group you come from, come. But the identity of each school will still be there. Even among those people from class 1, you know, you still want to identify who are those from this school, as from school B, the same thing. So you arrange all of them are ascending and descending on that bed. You must be able to tag them to know where they come from. So when you arrange that, you want to rank them. Because when you are ranking, you start with 1. The smallest number when you are giving rank is 1. So if there are 20, your rank can only be from 1 to 20. If there are 50, all of them, your rank will be from 1 to 50. Now, when you rank now, you know there will be some of them that have the same value, like 6, 6, 35, 35, 35. So that is potential, and because when you just number them 1 to 20, but it will not fair. This is 6, this is 6. You rank this one 3, you rank this one 4. All this one 35, 35, 35. You rank this one 16, 17, 18. So you have to now correct it and now do what is called actual ranking. Actual ranking is for you to now go to all those ones that have tie rank, that have tie value, not rank. Tie value, well, tie value like 6 and 6. You now combine their rank and find average and divide it among them. Just like when they say 2 people became second. The second this in price, they have to share it. Or the price for the second and the third, both of them will now make money together and share. So if you look at the 6 and 6 is the same value, but they are ranked 3 and 4. You now say 3 plus 4 making 7 divided by 2 with 3 points. Now give you each of them 3.5, 3.5. When you come to this one that are 3, 35, 35, 35, and the rank is 16, 17, 18. You now add it together, the 3 together, divide by 3, give you 17. You know, 17 is the average, and 18, give you 17. So you now give all of them 17, 17, 17. So that is the actual rank. So it's the same thing you do. You know, this is for when Sunday also the same thing. Somebody is this kind of day journey, and are you the one meeting on it?
Yes, yes, sir.
And mute yourself if you are welcome. Yes. So I don't know if we have. Before we proceed, I want you to ask questions, because this all these not parametric, they are not difficult per se. It's because we are not used to them. So I want us to ask questions. Though it's illogical, because if by the time you know how to use SQL to run it, you don't need to bother yourself. Most of us, since we are lecturers, because many people ask why. So it's just the logic behind it. And that is why for explaining, you usually use something that is manageable. We cannot be using maybe 400 samples like 400, 300 to be explaining this type of thing, because where to write it. But it's the same logic. So we thank God that the computer will run it for us. But we just use all the small samples to explain the logic behind it. I don't know if there's any question concerning what I've explained. This is for independent group. So what you do now, you combine the 2 groups, you arrange it according to, we mix all the 2 groups, then you arrange it in ascending order. Smallest first. You see, within the identity, you know where each of them come from. Then you now do, if there are tie value, tie rank, you now do, give the actual rank, divide the rank between those ones that are tie. When you finish, all you need to do is to now count. Those ones that are alcohol, those ones that are drug, you count their own rank, the rank of alcohol, the rank of drug. Like now, if from what you are seeing now, those smaller side is like alcohol tend to be on the small side. That's usually all those initial values. They are from alcohol. The larger value, most of the larger value are from drug. So by the time you now have the ranks for alcohol is 59. The rank for drug is 151. So you can see that the rank for drug, the addition of the rank for drug is higher. And the same thing, if you look at on Sunday, the same thing. We had on Sunday, the addition of the rank for drug is 119.5. For alcohol is 90.5. So Wilkinson statistic Can you see? It's not calculated apart from ranking and adding. He said the smaller of the value is the statistics.
Statistic.
Can you use the statistic? Thank you. The smaller of the value is the statistic. Very simple.
So Wilkinson is 59.
Is there any question? Is there any question concerning that? Wilkinson statistic here is the smaller when you sum. That's why they call it Wilkinson rank sum. After you rank, you sum. Wilkinson rank sum test. When you do it between the two groups.
I have a question.
Yes, sir.
I have a question.
Okay, sir.
This rank, the sum of ranks for drug is 151. I thought the drugs were the drugs were the ones above, or are they the ones below? If we make it upright vertically, like the first slide you showed, the drugs were on top, then alcohol was at the bottom. Drugs on top, 1 to 10. Then alcohol, they have the
11 to 20.
11 to 20.
This is just an arrangement how you enter it. It's just that the way one can enter it into SPSS or in a table. That number
But now, if
has nothing to do with rank.
Sorry.
Okay.
Yes, I'm coming. If you now turn it,
yes.
If you now turn it in a horizontal direction, that's like that. So the first, I expect the first ones to be for drugs.
Okay, thank you.
And their ranks are lesser. So how come their own is 151?
You said that the lines are lesser. Which one is lesser?
The drug.
It's not lesser because each of them are 10. No, each of them are 10. Even if you look at the drugs, if you look at their, look at Wednesday. Look at Wednesday. Because the first one you are seeing up is Wednesday. Look at the score for drug on Wednesday, 20, 30, 30. Look at the score for alcohol on Wednesday. Can you see? Hello?
Okay, it's okay. It's clear. It's
okay.
Clear.
Now,
sorry for
I want you to see here is that
I was taking
it's not we didn't just teach the table. We have arranged it in ascending order. We have mixed all of them together and now arranged it the smallest to the highest score. The score.
Okay.
We have arranged before. Now this one is just to put where each of them come from. Is it alcohol? Is it drug? But after you have arranged in ascending order, this one is to tag it that this one is alcohol.
Okay, yes.
This one from
yes. Sorry, I've gotten it.
Okay, you've gotten it now. Any other question?
I've gotten it.
Okay. Any other question? Any other question? Any other question?
No.
No question, right? You continue. Okay. Now. Come on. Okay. Yeah. So let's continue. Now, when Wilkinson, if you look at it now, the statistic for Wilkinson for Wednesday now is 59 because you see the smaller one that is the statistic. The second one for the Sunday, the statistic is 90.5. So if we look at, okay, let's just continue. Look at it. Now, in the example, the test statistics are 90.5 and 59 for Sunday and Wednesday, respectively. That's Wilkinson. Then, Mark Whitney now come with this formula. So, to now feed in can you see the sample size plus one of the sample size, then over 2, this is the formula minus R1. R1 means higher sum rank. The sum, Wilkinson choose the smaller sum rank as the statistic. But this one feeding all this computer put the two sample size, and also R1 here is the higher sum rank into its own formula to give the statistic. So this is Man Whitney used for Sunday and Wednesday. You can see for Sunday is 35.5, for Wednesday is 4. So we're going to see, if you look at this statistic now, because we know that the smaller the statistic, the more significant it's going to be. So if you look at the example of a table I show you, I show us the Wilkinson table. If the sample size, this one is not a complete table anyway. Like for if the sample size for this one is 20, I expect the cutoff point to be greater than this for 0.05. So at the end of the day, you're going to see when we run it, or after running it, I think the result is here, the same result. We are going to run it. After running it, you see the output. You see the sum of the rank for Sunday, for drug, 119.5, the one we got. For alcohol, 90.5. The statistic, Wilkinson statistic is 90.5. Can you see here? Wilkinson 90.5. Man Whitney, from what we calculated for Sunday, is 35.5. Then, if you look at for what do I call it, for Wednesday, Wilkinson is 59. Look at it here. And Man Whitney is 4. So you can see that for Wednesday, the difference between drug, depression among the people that use drug and between the people that use drug and alcohol, the difference is significant. Look at P. So this Z is just a formula. Okay, if the sample size is becoming big, you can transform this Wilkinson to Z distribution. That is, normally you know that whenever anything that doesn't follow normal distribution, or if the sample size increase, the probability that it will follow normal distribution, is high. So with the sample size increasing, this is the corresponding Z. But all of them, they share the same p-value, just the corresponding Z. So you can see now it's less than 0.05. It means that it's statistically significant. Therefore, this one is more than 0.05. This one is not significant. So you will see from either Wilkinson or Man Whitney, the smaller the value, the more significant it is. And that's the only statistic that behave like that. The Wilkinson and the Man Whitney are the only statistics that behave like that. Many other statistics, all that statistics are the opposite. Yeah, it's opposite. As the statistic increases in value, it will reach the critical level. If it increases more than that, it will be significant. But this one, it is when it goes below the critical level. So at the Wilkinson and Man Whitney decreases, the more it's likely to be significant. That's just the logic. What I will do is that I will find out if
I have a question.
Share.
I have a question.
Okay, go on, sir.
Yeah, the question I have now is that if we take the lower table of the output, we see that significance for Sunday is 0.269, 0.269. What if I'm making a statement about the significance? How are we going to put it? Can you just help me put it that with respect to this and that?
Okay, well, the way you're going to say it is this. There is no statistically significant association between the depression of people on drug and alcohol, and I say P is, and I say 0.269. You can say it's less than. Before you don't need to say it's less than, just put it there because you have already chosen 0.05 as your level. It's in those days when we don't actually have access to the p-value, no computer. We will now say that p-value is greater than 0.05. People will know that once the p-value is greater than, that's why the probability of making one error that is probability of the difference you are seeing due to chance is very high. It's higher than 0.05, higher than 5%. But now, Or if it's like this other one now, you say, oh, there's a statistical significant association between the depression, in the depression between drug user and alcohol user on Wednesday, because the p-value is 0.00, maybe less than 0.001. So in those days, you just say the p-value is less than 0.05. But now the value is there. You just quote the value.
Exactly.
So everybody will now
Yes,
know that
okay.
that value you have quoted is either greater than 0.05 or less than 0.05. If you have chosen 0.05 as your level of significance.
Okay, now, as why I asked this question is that I'm not too used to this parametric, so I'm enjoying it now. I'm
No,
just
it's the
learning.
same thing. It's the same p-value. The funniest thing about p-value hypothesis testing, once it now reach p-value, it's the same interpretation. The way you interpret even parametric, the way you interpret non-parametric.
Okay, so my question is, so this non-significance of the drug and alcohol is not a comparison whatsoever with that of Wednesday. We will now say that the one of Sunday there was no significant difference.
Yes.
For the one of Wednesday there's
significant difference. Yes, exactly.
But the way we table it in the SPSS is like we wanted to compare. Okay, so we are just testing on the different days. Okay, I've gotten it.
No, yes. We have done 2 tests here now. We have we are so Wednesday may not be there, maybe only Sunday. We can just say depression on Sunday or just depression. It's because we measure depression on 2 days. We now do the 2 days separate. So each of the day is separate. Yes, I mean, each of the day you are looking for difference between alcohol and drug. So why I put it like that is that maybe I should separate it. But why I put it like that is that this same data set now we're going to use it for, I said it from the beginning, for the pair. When we want to use for the pair one now, it will be that we are looking at the difference between Wednesday and Sunday for drug separately, Wednesday and Sunday for alcohol separately. Can you see now? You say somebody say you cannot hear me. You cannot hear me. I can hear you now.
I can hear you now, sir. I can hear you now, sir. It's like I see.
So do you have a question?
Yes, sir. Yes, sir. So I remember you making a statement.
Okay.
For that, in that output table, where you were saying that for the man with Neo and the Wilkinson, that the higher it is, the higher it is, the more significant. Like I wanted to just explain that difference. I understand the manual calculation, the formula. I understand that, but I wanted to understand what you meant. When you say that the higher it is, the more.
Didn't get me.
Thank you, sir.
I didn't say the lower it is, the smaller it is, the more significant. For my Whitney and this and Kinsey, the smaller, the more significant.
Okay.
Other statistics like t-test, chi-square, any other statistic, the higher they are, the more significant they are. For my Whitney and Kinsey, is the opposite.
Yes.
That's what I said.
Okay.
That's the values of the t-statistic.
Yeah.
Okay, and then for the chi-square statistic.
Okay, should we continue? Should I go to this other one? Yeah,
yes, sir.
Okay. Let's go to now. Okay, let's run it now. Or we should, as you explain this one, go and run them at the same time. Okay, let's just maybe we'll go and run it at the same time. Now, the Wilkinson is already there on the table. Whenever you are having the same group, you are comparing before and after. For example, now, the measurement on Wednesday and Sunday. Measurement on Wednesday and Sunday. If we look at it, here, if you remove, can you see the way we are arranging now? That's for this drug, Sunday, Wednesday, alcohol, Sunday, Wednesday. Now, if you remember for the independent, for Whitney and Wilkinson, when it comes to here now, there's no Whitney here. It's the rank some tests that one weakness is related to. But for the sign rank test, there's nothing like one weakness. This is Wilkinson sign rank test. The other one is Wilkinson rank sum. If you look at, we rank it and sum it. But here, this one has sign. And what makes it have sign? Because you are minusing. So if you minus, let's say Sunday from this Wednesday, look at the differences. So if you look at it now, consistently for drug, all the Wednesday measurements are higher than Sunday. So when you remove Sunday from Wednesday, they give you all of the positive except two that are the same in value. When they are the same in the value, it gives you 0, 0. This is 0. Anyone that is 0, that the value are the same on both days, is not part of the calculation again. Look at it, exclude. Look at the sign. Plus, this one excluded is 0. There's no sign here. Plus here means that is positive. The value is positive. All of them are positive for drug. But if you come to alcohol, some are positive, some are negative. Can you see? Oh, when you remove this Sunday from Wednesday, this one, 16 minus 5 minus 16, it will give you minus 11. All those ones that this one is bigger than will give a minus. But all this one that this one is smaller than will give you plus. So you now separate them. Okay, minus, minus, plus, plus. That is where you carry the name. You get the name sign. After you have, by minusing, you are able to LEC give sign to each of them. Now the next thing is for you to rank. You rank their value irrespective of the sign. Irrespective of the sign, forget about the sign. You know, if you consider the sign, anything that is maybe minus, like this one now, the one that is minus 15 will be the smallest when you are ranking. But no, you are ranking the absolute value irrespective of the sign. So when you rank now, if you look at it, the smallest one is, you are ranking the difference. Is 0 is excluded. So you cannot, yes, 0 is excluded. So apart from 0, what is the smallest one? Is 6. That's why it's given rank 1. What is the next one to 6 here? Is 13. Can you see? But there are 2 of them, 13, 13. So it's supposed to be 2, 3. So because you remember the way we did the other time, because both of them tie, 2 plus 3 make it 5, divided by 2, it will be 2.5. Each of them will be 2.5, 2.5. Then the next in rank is 15. The next in the different, the value is 15. And there are 2 of them also, this and this. So it's supposed to be number 4 and 5. When you have 4 and 5, making 9 divided by 2, 4.5. So you now put 4.5 for each of them. And the next one will be 19. 6. 96. Then next one will be 20. The next one will be 23. Can you see the last one? 23. So you've ranked them now. You have given them the rank. Now you now want to separate. You did the same thing. You know there are 2 separate things now. Drug is being treated separately. Alcohol is being treated separately. If you look at the alcohol side, you see if you rank it. So you now separate. The next one is to separate the positive rank from the second negative rank. That is the rank of those ones that are positive from the rank of those that are negative. You know all of them are positive here, so that's all of them are here. When you add it together, it's 36. The known is negative, so 0. Here, the positive rank. These are the positive rank. The positive rank is only one that is positive. Can you see? It's only one that is positive here. Is this rank 8? The remaining one are negative. Now add them together. Look at it, 47. So for drug now is the positive, total positive is 36. The negative is 0. 0 is the statistic, or is the smaller of the 2. That's the Wilkinson statistic. For the alcohol, the total for this is positive. The total for this one negative is 47. The 8, the smaller is the weakest. So it doesn't, when you just know the smaller, it doesn't really matter. You will not put the sign when you are saying this is the statistic. Just say that is the statistic, or that is value. Look at it. For draw, T total for positive 36, total for negative 0. For alcohol, total for positive 8, for negative 49. The test statistic is the smaller of the two. 0 for drug and 8 for alcohol. It's very simple. Is that also? It's very simple. Any question? So let's look at the results. The same thing. If you look at it, when you run it, negative, the total for negative rank for drug is 0. For positive is 36. For alcohol, the total for negative is 47. For positive is 8. So the smaller one, 0 and 8 are statistics there. And give you the P. Any question? Before we go to the median test. That median test.
Sorry.
Yes,
Before
sir.
you go to, well, of course, this most time we know we have SPSS. Like you have T tables, you have Wilcoxon's table like that where you check the test statistics to know whether.
Yeah, easy. Yes, there is. Yes, there is. There is. Okay. So when you all you need to do is that you look at the critical value for the sample size.
Yes. It's
an example extract I just put here. Look at it. It will show you sample size, the critical value 2T, like 0. You have to know your level of significance you have set. We are not using 0.0, we are using 0.052T. This is place. So you now know this what you are having is the critical value for that sample size. So anything that is less than that critical value will be significant. But if your value is more, it will not be significant. So that is the something.
So the exact value we cannot really know if we use the table, Abi.
The exact value?
Yes.
No, you cannot know now. Even even other statistics, you don't see there. When you calculate the exact value, what you see that you see the critical value. You want to see if what you have calculated for other statistics, if it's greater than the critical value. That's the way it is now. It's like chi-square now. You know, for the critical value for degree of freedom 1 is 3.84. So when you calculate chi-square and your degree of freedom is 1, you have to know your degree. You now go and look at the table, okay? Degree of freedom 1, under 0.05 level of significance, you see 3.84 as the critical value. If your chi-square is not greater than that, that's is significant. That shows you your p-value will be less than 0.05. Okay. So it's the same thing here. You look at what you calculate against the critical for that sample size. The examiner, you see if what you have is less than. Here now you are not talking of greater than, it's less than. Okay. It's the same principle.
Okay.
Any other one? So it's because people are not used to it. That's why it looks somehow. But once you just know the logic. Any other question? It's so simple, right?
Let's see that output again. Sorry.
Output, okay.
The output we just showed us now. The output for
look at it.
Okay.
If you look at it, both of them are significant. Both of them. If you look at it, if you see the Wilkinson of 0, Wilkinson of 0, and in the sample size we are talking of each of them is 10, and the Wilkinson of 0 and 8. If you look at the example I gave here, look at it. The critical value for sample size 10 is 8. Can you see? Can you see now? That's why both of them are significant. Yeah. So anything 8 or less will be significant for sample size 10, and that one is sample size 10 also. The one we just did. Yeah, each of them is sample size 10. So You see, that is why both of them are significant. If you look at it,
yes,
the one that is 0 is the drug holder is 0. Is the most significant. Yes, I mean, can you see that the Wilkinson is 0 is the most significant? Why the other one is just barely significant?
Sorry.
So any other? No question.
Okay,
Right?
thank
Let's
you.
go to media.
Thank you.
Welcome.
So, but this one now that we are used now, we are still taking Wednesday and Sunday. I'm sorry.
Maybe,
we are still taking Wednesday and
I should
Sunday.
go and separate this thing. Maybe what I will do is that I will separate.
No,
I will go and separate this thing. So I will just use.
No, because we started with paired. So the pair is drug and alcohol. The pair is not necessarily Sunday and Wednesday.
No.
The pair is alcohol and drug on Wednesday. Alcohol and drug on Sunday.
No. The pair is Wednesday and Sunday. The pair is Wednesday and Sunday. It's the independent group that is drug and alcohol. I don't know if you understand. Drug and alcohol mean that some people are taking drug, some people are taking alcohol.
Okay, so
you want to see their depression. It's only that we just say, okay, you do the depression for Wednesday, irrespective for Sunday. You may not do for Sunday, you can just do some Wednesday. Comparing depression between drug and alcohol user, that is independent. But when we come to the pair now, we can decide to talk about,
okay,
don't let us talk about alcohol, let's just focus on drug.
Yeah.
Let's focus on drug alone.
Okay, so we have done.
Go on.
So we have done the pair now for Sunday and Wednesday. This process we did.
Yes, now is the pair now.
Whether there's any difference between.
If you look
Wednesday
at it, what do you?
Okay.
We just run it separately for
the
drug.
Equivalent of the paired.
Yeah.
Okay,
what
for Sunday and this thing. Okay, so is the.
Okay, let's go.
So is the corresponding one for the paired test.
Yes. Let's go and run it now. Let's run it. Let me have read it. Yes, this is the something. This is the. Can you see? Can you see it? Can you see
yes,
the SPSS?
I've seen it.
Let's first of all run the.
Yes.
Want to run it as be independent. I want to first of all do the first one independent between drug and alcohol. Between drug and alcohol. So analyze non-parametric legacy dialogue.
Okay.
Now two independent samples. You know there are two independent samples.
Okay.
Now see. So yeah, I put both. This one is for Sunday and Wednesday. I can decide to run only Wednesday. Yes, I mean. Let me just run only Wednesday. Yes. Go on.
Listen, I wanted to, because this was where I came to when I was testing. Because I wanted you to start from the beginning. Let's see if you can move it back. If you can move the substance, I want to just do the steps. Thank you, sir.
Okay. Okay. So can I proceed now?
Yes, sir. Yes, sir. Thank you, sir.
Okay. When I came here, okay, because that was the last procedure I did there. That was why I was showing it. Let me move them back. Don't worry. So this is depression. These are different. I can decide to say, okay, I want to run depression on Wednesday. That's the only variable I want to run. It's open that I put two variables there. I don't know. I don't want it to confuse you. I want to run the depression. That depression was measured on Wednesday for between May and between drug and alcohol. So what defines drug and alcohol is this substance used. And I put it here. We have coded drug as 1 and alcohol as 2. Now put 1 and 2. My witness here. Now click. Let me share the output. So okay, yeah. I think I'm coming. because I did something before. I will, because let me just go back there. You know, I was running where I ran the pair. I splitted the data. I've not taken it back. That's why I did that. So let me do it now. Non-parametric. So look at the results. Can you see? I just run. This is a variable, the pressure on Wednesday. Okay, maybe I've not shared it.
You've not shared the output. We have not seen the output.
Can you see it now? I've shared it now. Can you see?
Yes.
Yeah. So you see, drug.
I'm seeing.
Okay. What am I? Okay. It's only where is the drug alcohol?
We're seeing now. We're seeing the output.
Okay. This is anyway. I don't know where it's bringing it, but the issue there that is where I'm running. Okay, this is a group. Yes, drug and alcohol. Depression on Wednesday. You see the Wilkinson is 659. That is when you look at the sum of the rank. You do the other time. The rank for drug is 151. For alcohol is 59. The smaller of them is the statistic. That's why Wilkinson is 59 here. Then when we calculate the Mann-Whitney is 4, and it's significant. So I can go and do the same thing. I say I want to run for depression on Sunday. It's another variable between drug and alcohol. I don't know if you understand now. So because sometimes when the way we put them together is confusing many people. So I decided to say, okay, it's depression on Sunday I want to run now. Can you see? Can you see that? It's depression on Sunday. Can you see? You know that one is not significant because the Mann-Whitney is 35.5 and the Wilkinson 90.5. So does it make sense?
Okay.
So let's now go and run the pair. Okay, before I run the pair, I don't know if there's any question concerning this. Any question? Oh, any question concerning this before I run the pair?
Hello? Hello?
Yes, I'm listening.
Hello?
I can hear you. Go on. We are hearing you.
Okay, sir. Sorry, you were breaking. Okay. I wasn't hearing you again. When you were now explaining the
it's your end though, because every other person is hearing me. It's your end. So what's the question?
Yeah, okay.
What is the question?
No, the part where you were now doing the Sunday table and
it's the same thing.
Wednesday table separately.
Let me just show you. It's the same thing. It's the same thing I show on Wednesday. I run the Sunday table. Look at it. It's not significant. Okay. Separately. You look at it.
Oh, okay. I understand now. Okay.
The total sum for drug is 119.5. For alcohol is 90.5. And the smaller one is the Wilkinson 90.5. And it's here. Look at the Wilkinson 90.5. And the Mann-Whitney 90.5. So it's not significant because the value is high. The other one is smaller. For the Wednesday, the value is smaller. So
the smaller it is, the more yes.
It will be significant.
Dr. Dolapo.
Yes, sir.
Oh, please, something is just running through my mind now.
Okay.
Like this data set now, have 2 separate days. What you've done is to run like Sunday and Wednesday as independent sample, and then Wednesday.
No.
Drug and alcohol.
Drug and alcohol.
Drug and alcohol as independent sample for a particular day.
Yes.
Yeah, for a particular day, yes.
Exactly. You can also run drug and alcohol. Will it make sense to say do independent sample for Sunday and then go to Wednesday and do independent sample for Sunday and now look at which one will be more significant? Is it likely going to yield the same result?
I don't understand what you are saying because they are those Sunday and Wednesday. In that sense, when you are considering the difference between drug and alcohol, yes. Those Sunday and Wednesday, they are separate variable. It's just like I'm trying to look at age between
rural urban.
Rural urban. I also want to use that BMI, rural urban. So age and BMI, they are two different things. The depression on Wednesday and on Sunday, they are two different things.
Okay. What I'm saying now is that for each day, you can run the data set as independent samples. Abi?
Yes, yes.
So can you run independent samples? Maybe you run for Sunday as independent samples and you don't get any significant value. You now go again and run for Wednesday and you now get a significant value. Does it make sense?
Exactly what.
Does it make sense?
That's exactly what you have done.
Yes, you can. Yes, that's what we did. But you can interpret it and say that okay, there is no difference in the depression between alcohol and drug user on Sunday, but there is difference between them on Wednesday.
On Wednesday.
Okay, fine, good. If you now do a peer test,
that's what we did. Yes.
Yes, if you now pair them, is it likely going to yield the same output, the same interpretation?
No, it's not. It's different. It's not the same interpretation because the output. That is what we now do. Let me now do that one now. That is what the next one want to do now. That is the pair. Let's now run that one.
Let's run the pair and see.
That one now, you are now running it. You are trying to compare what happened on Wednesday and on Sunday. For drug users, what happened on Wednesday and Sunday for alcohol users separately. I don't know if you understand me now.
Exactly.
Yes. And in that one, you have to, first of all, go to data and split. Because we do it together, we have to split the data into alcohol and, it's pairs. And yes, so that it can run, so that it doesn't run it together. I have to split it. That's why I now come here and now split it. Go on. So I've split it. You are following me?
No, I wanted to do the splitting like first.
Okay, go on now.
The method of splitting.
I want to know where you went to.
Okay, go to data.
The technique of splitting.
Okay.
Go to data.
Oh, split files. Okay.
So that I think we did how to use SPSS data.
Okay.
Go to the split. That's the third to the last something there. Split file.
Yes. Yeah.
You click on it, you see by default, it check the analyze all cases, do not create group. That's default.
Yes.
What I click on is the second one.
Yes.
Compare groups. Click on compare groups. When you click on the space below is highlighted. Now move that substance use. Move the substance use into that space.
Okay, I've done that, sir.
So click OK. When you do that, you have split it. So we now want to go and read and run analysis now. You now say analyze non-parametric, legal dialogue, two related samples. You remember?
Yes.
Click to legal. You now move them into the space. You can click both of them and just move it. It will now be
move them.
Yeah, variable 1 and variable 2, move them into that space. By default, it check Wilkinson. You can also check sign.
Okay.
By default, the Wilkinson is checked. You can also check sign.
Okay.
So have you done that?
Yes, sir.
Okay. Instead of you to be demonstrating to us, you are doing it alone there. Yeah.
Sorry, sir.
Don't share.
Okay, let me share now.
Is there? It's shared.
Okay, yes, it's there because that is the space where I went for it. Okay, can you see? So it's so Dr. Balogun, can you see now? What we have just done now is that we have done pair separately for drug user, separately for alcohol user, separately. Can you see now? That's why it give you two. This for drug. You can see the negative rank. What we did, the sum of the negative for drug, if you remember, is 0. The sum of the plus is 36. And by Wilkinson standard, 0 is the statistic. Then if you come to alcohol, the sum for the negative is 47. The sum for the positive is 8. By Wilkinson, the 8 is the statistic. Look at the p-value. Does it make sense? You will see that the drug, what this one is telling you is that the difference, there's a statistical difference in the depression between Sunday and Wednesday depression. The depression of Sunday and Wednesday among drug users. The same thing among alcohol separately. But if you look at the p-value, it's more among drug users. The difference is more among drug users than
alcohol.
So on the 2 days. Okay.
But so you are looking at difference between the 2 days now. You are not looking at difference between alcohol and depression between alcohol user and drug user. That's what we did before. But what you are looking at now, the depression among the drug user. What is the difference in their depression between Wednesday and Sunday? Then for alcohol user, what is the difference between their depression between Wednesday and Sunday? Does it make sense?
So, yes, so Dr. Kolapo, sorry to take you back. I just want to really get it right. Now, in both cases, there is statistically significant difference in depression scores.
Yes.
But that of drug, the p-value is less than that of alcohol.
Yes.
So the lesser the p-value, the more effective.
The more significant.
Yes, the probability. But that's what we usually say. But sometimes it may not work like that. That is why we usually use that measure of association. Something may be even more significant, but it doesn't actually, you look at it with the p-value. It may not actually more have effect. It may not necessarily. It's just the difference in their probability.
Okay. So what you are saying in essence is that in both cases there is improvement in depression score.
There's a trend in between Sunday and Wednesday.
For that of drug, the p-value is less. So does it mean that p-values can be compared from different, experimental groups?
That is why many people come with all this odds ratio and relative risk. Yes, it's not advisable to do that because there are sometimes you can do some study, the p-value maybe 0, maybe less than 1. But the odds ratio of the other one maybe even be
very high.
Higher. The one that have bigger p-value. Do you get the picture? Yes. So sometimes that p-value is just probability that is just, probability is something that you're just something likely or not. If you say that the probability that it will rain today is 0.9, very high, it may not rain.
Okay.
If you may say the probability that it will rain today is very slim, it may rain. You get the picture. It's probability.
For us to make any conclusion from these two different probabilities now, can you now add the calculation of maybe odds or risk ratio as the rate may be, and then say this is also this significant, but with a higher risk ratio? I don't know how you can put it. Are you saying that we need more statistical information before we can conclusively say that because this one has a lesser p-value, definitely it is more efficient than this other one?
Okay. Yes.
Because I'm comparing it, when you use a placebo, for example, now, and you are getting something significant for your drug and the placebo. And parameasure, the placebo has a lesser p-value. Are you going to now say that placebo, because of a lower probability, is more efficient?
No, actually, no, people still make the conclusion because it just guiding your conclusion. That is, you are more apt to conclude that there's a difference between the depression between Sunday and Wednesday among the drug users than the other one. But it's going to be difficult for you to quantify it unless you want to go and calculate odd ratio. You can do that. If you want to do that, you can do that and go. But where we go to have problem with that one is because you are dealing with pair. You can only easily calculate the odd ratio with the category independent. Yes, the pair something because it's the same group of people before and after. You get the picture now. What you well, that's just it. But you can still conclude that from what we are seeing now, you can easily conclude that the drug, the probability, what is just telling you is that the probability that the difference you are seeing in the drug and the where you are seeing the depression on Sunday and Wednesday among drug users is due to chance is very smaller than that of alcohol. You get the picture now? It didn't quantify it, but you can still say that the probability is less. That is due to chance.
Okay.
You understand me now?
No problem.
So if you want to quantify it now, that's why we now use, that was why we call that one measures of association. You understand me now? It's able to quantify association. One has to be careful about, especially when it comes to correlation. You know, correlation, if you correlate two things, that's why if you look at it, where you don't interpret correlation with p-value self.
Exactly.
You rather say, no, maybe negligible correlation, moderate correlation, strong correlation. You know, if it's 0 to 0.2, negligible, 0.2 to 0.5,
medium,
0.5 to 0.8, moderate, 0.8 to 0.99. That is strong, but 1 is perfect. You won't use p-value. The reason being that if correlation is very big correlation, if the sample size is very big, it may not be significant. Small correlation. If the sample size is big, it will be significant. Big correlation, if the sample size is very small, it will not be significant. But big correlation, if the sample size is very small, it will not be significant. Can you see? So whether the correlation will be significant now, p-value depends on the sample size. So that is why people don't interpret correlation with p-value. That's the drawback of p-value, and that is the drawback of parametric, non-parametric test also, because you are dealing with the rank. You are not dealing with the exact
real value.
So it's going to be difficult. Apart from the p significant, also you cannot make any other thing reasonable. Whereas if the other one, you can say, okay, let me combine it with confidence interval, because if you calculate the difference, you know this is the difference, is the real difference from the data. I can be sure that in the population, I'm 95% confident that the real difference will be between this and this. That is where you are doing parametric better. Here you are handling the rank. Though this one does not stop you from doing, if you use non-parametric, you can still go and use confidence interval to be able to know the real difference. Are we together?
Please, sir.
Yes, ma'am.
Yes, sir. Please, sir. Does it mean that odds ratio cannot be used, because this is the rank we use?
No, that's not what I'm saying. You know, when you are talking of this odd ratio, it has to be with category. If you want to do odd ratio here now, we have to now categorize the mark between between drug and alcohol, and have the cutoff, I say high and low. You get it? If you all those depression score now, if we have a cutoff, I say okay, any depression score that is
or more or less than 20.
If you want to say normal or low, so we categorize into two. Yeah. Then you will now have two groups also, which are on drug and alcohol. So we can calculate the odd ratio or relative risk or odd ratio. We can calculate the odd ratio. So because the odds ratio, we go with categorical. That was why the training we did. Okay, were you part of the training on the chi-square? Weekend training on chi-square? You were part of the last one now, Abi?
I think I was. Oh.
You are not sure.
I can't even remember. But
no, you were on and off.
I can't even remember.
Yeah, you were. No, she was there, but she was not.
No, I think she was not there. It was. I think it was SPSS you did. All right.
Is it not Ugonaya?
Yes.
She was in the.
Yes.
In the
okay, she was. Yes, she was there. Yeah, she was there. Well, that's good. That's good because
I've seen this name there.
Okay.
I've been seeing her.
Yeah, that is why I try to combine that odd ratio combined with chi-square because it's dealing with categorical. Do you see the logic now? So
yes,
if you have to use for this one, you must have to dichotomize the depression score. When you dichotomize the depression score, you can now use it to really know which one caused depression between drug and from what we are seeing now is there's a clue that drug caused depression more. But it will be able to tell you how many times more likely that the drug will cause depression more than alcohol. Dr. Balo, can you see your question now? How many times depression is more likely to be caused by drug than alcohol? Because from what we are seeing now, it appears that drug causes depression more than alcohol. When you do the odd ratio now, it gives you a quantification of how many times the drug is the likelihood of drug causing depression more than alcohol causing it. That's measures of our association. Can we proceed?
Yeah.
Yeah. Okay, let's quickly look at the last one, median test. Median test. That's the so can you see the slide? Can you see the slide? But if you see somebody, you just let me know.
I'm still seeing the old one.
The output, yeah. Oh yeah, example 7. Yeah, we are seeing example 7.
Example 7 now.
Test.
Yes.
Median test.
We are seeing it.
Example 7 is there.
Yes, median test. So this median test also is a non-parametric. If you look, the sign test also we run with that Wilkinson pair or one sample. If you look at it, the sign make use of the median. That sign also is a form of median test. It's not as if you are comparing them. People think maybe it's a median test because people keep on asking the question. Even when I was one of the lectures on Tuesday or Thursday, somebody said that is it not the parameter is median is comparing. You just take okay from the one we have done now. Wilkinson, Whitney. Did you see any median? Do you compare any median there? You didn't compare median. You didn't compare mean. You didn't compare any of them. So mean and median, none of them came into picture. But this median test. Apart from that sign test, the one we did yesterday. So the sign test is a form of median test. Even the median test comes in. It's not as if you use median, you are not comparing median. You just use the median to divide the data set into 2, you will see. So it's a non-parametric test that's used to test whether 2 or more. Can you see? One thing with this one, why I take it last is that it's not only for 2 independent groups. It can be for 2 or 3 or 4. And you know that for parametric, t-test compare 2 groups. ANOVA compare more than 2 groups. But this for non-parametric, this median compare 2 or more. Can you see that? That shows that this median test is a non-parametric counterpart of independent t-test and ANOVA.
At the same time.
Yeah, at the same time, and one way another at the same time. So now you will see also it reflects in the way we are going to run it with SPSS. So that the question, that question Professor Etokide was asking, is going to happen again. Where you're going to look for it to go and run it is somehow. And that just it. The do is more straightforward than the other one, like the science test. This one is more, at least ab initio, we know is for both 2 samples and more than 2 samples. The principle of the test is that if 2 samples have the same median, it should have more or less the same proportion of observation above or below that median. That is, if 2 samples have the same median, if you mix all of them together, it will still be that value will be the median still. And if both of them should have equal proportion above the median and below the median. What I mean is that if this one has 40%, of course, the median is the middle value now. That is, half the central median for all of them. Both of them should have equal proportion above and below. Half of this should be above together with half of this, and half of this together with half of it should be below. That is the logic. So if you look at let's just go straight to the example. It's quite interesting. Let's look at this private bank. A private bank is interested in finding out whether the customer belongs to 2 groups belonging to differ in their satisfaction level. So these people, they have people that have current account with them. They also have savings account with them. So they now sample 20 people with current account, 20 people with savings account. They are separate 2 groups of people. They are independent. They do their satisfaction. They use like SK, to administer. And when they now do aggregate score, these are the aggregate score. You know, when you do like SK 1 to 5, maybe the question they are up to 20. So if they are up to 20, 1 to 5, 5 times 20 will be 100. At least the total maximum mark they will score will be 100. If there are 60 questions, the maximum one will be around 80. Whichever way, this is the aggregate score. Each person satisfaction score. Each person score. Now, how do you go about it? If you are to use, if you look at this one, it's not like the first one, the science test, where I said, okay, they have to give you a value, a median value in the population. This one, you have 2 populations. You can know their median if you want to know that. You have 2 samples rather, so you can compare. But actually, you know that you are not actually comparing the median, as you are going to see. Now, the same thing also, you first of all rank. These are the steps. To arrange the combined data, you first of all arrange, just like the way we do for ransom, we can see ransom test, where we arrange all of them according to from smallest to the highest, or from highest to the smallest. But this one we arrange it from highest to the smallest. Now, if you arrange, you know there are 20, 20. 20 plus 20 is 40. So if you arrange 40, which one will be in the middle? It will be number 20 and 21. The middle value, you know, if let's say they are 41 now, number 21 will be the middle. But because it's even number 40, the middle will be 2. So the median will be 2. And that median will, if you look at it, number 20 is number 20, and this is the number 20 is 62. Number 21 is 61. Number 21 is 61. Can you see?
Okay. Yes, sir.
So the median will be, the combined median for both the 2 groups together will be 62 plus 61 divided by 2, making 61.5.
Okay.
Now, you now want to know how many of this current account group have value above the median. How many have value below the median? The one that have value above the median, they are the one that have painted noted blue. And the one that have below the median are the red. if you count for this current, it's 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. 8 are above the median, and the remaining 12 are below the median. That is what you have on this table here. Current account above the median, 8, below the median, 12. If you now count for savings account, the one that have above the median, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 of them. The remaining 8 are below the median. You can see savings account above the median, 12, 8 below the median. It gives you 2 by 2 table. That is what the median does for you. That's all. So are you comparing median here now? Even though they call it median test, they just use median value for all of them to form 2 by 2 table. But if it is, let's say there are 3 independent groups now, when we are talking of ANOVA now, when we get to ANOVA, we do that. Median test, parametric for ANOVA. You're going to see that it will form 2 by 3 table. You get it now. You're going to form, you're going to have third group will be here, above the median, below the median. So at the end of the day, it will be 6 cell. The here now is 4 cell. So what do you think? It's chi-square. All you need to calculate is chi-square. So the median test, you also use the median to divide them into contingency table, just like what we have just done now, and calculate the chi-square. That's all. Does it make sense? Ask question before we proceed.
So, okay.
Ask question because
I have a question, sir.
Yes, sir.
It may not, now I'm trying to look at, assuming I want to do a client satisfaction survey.
Okay.
And kind of, let's say I did, I scored the clients, how satisfied they were with services.
Mm-hmm.
And then I institute an intervention, something, I institute an intervention, and thereafter, 3 months, 6 months after the intervention, I run another client satisfaction survey, and I have the scores for both pre-intervention and post-intervention.
Yes.
It is not going to be the same clients necessarily. It's not going to necessarily be the same clients, but just clients generally. So which of these tools would I use to?
That is what you do in community. You say you are doing community intervention. Because
yes,
when you are not dealing with the same, you treat them as, you are not treating them as independent, because you cannot pair them. But normally the logic should be treated as independent. If it's going to be exactly like this, that's what most of our people do when they do their, what do I call it? They say they do their interventional study. They will have 4 groups, all those 4 groups. We have experimental and control, baseline, experimental and control, post. That's baseline, that's pre-intervention, experimental and control, post-intervention. Because those post-intervention, though it's from the same community, but it's not exactly the same people, they sample separately. So they are independent groups. The way you treat them, you cannot treat them as peer. You treat them exactly like this. I don't know if you understand me.
So is it this median test, or is it the...
No, the issue there is that the issue of median, before you even jump to the issue, hold on 1 minute. Okay. Before you even join to the issue of median or non-median, you have to first of all know the type of, this median now we say, for 2 independent or 3 independent, you have to first of all know what you are dealing with. Are you dealing with 2 independent group or peer group? What I'm telling you now is that scenario you just said now is independent, because you did not pair, in the sense that if you pair, it's the same set of people you go to, and if Beatrice is number 1 person, the score of Beatrice 3, you must be able to know when you are entering is under number 1. Pre will be under, for Beatrice will be under number 1. Post for Beatrice will be under number 1 in front of it. That is the real pair. You understand me now? So yes. I'm telling you that most of our people, that I was asking Ugo Naya, when they want to analyze for Duce, I think it was pair, because you have to pair. Only people that pair.
You have to experiment. Yes.
Yes, it's pair, because you have to because he said he went back to the same set of people when after he did education for them, he went back. He's able to trace that this is the questionnaire I administered for this person, and this is the questionnaire I tied together and enter in the same line. But if you didn't do that, maybe you went back, you sample another group of people, because they say it's a community intervention, because it's not necessarily that it's different sample, even though it's pre and post, but they are independent sample. You treat them as independent sample. So when you have the tool like that, it's independent sample. You're going to use this one as non-parametric. You can use the median. But if it is paired, you're going to use the one we just finished, Wilkinson pair. Yes, the Wilkinson sign rank test. Prof, have I answered your question?
Can we also use the Mann-Whitney U since it's independent?
Okay. Yeah, you can use Mann-Whitney U. Yes, you can use you know, in this class we are just trying to explore the different one they use. And let me tell you, you're going to see that the Mann-Whitney U is more powerful than median test. It's more powerful than median test. But the only good thing about this median test.
An extension.
It's not an extension, because the logic are different. It's not an extension. It's more powerful.
Hello, sir.
Yes.
Sorry to cut you, because I was a bit confused. Is there any way related to Kusawa, or it's quite different?
Well, it's quite different, because by the time we do ANOVA, Kusawa is also the non-parametric counterpart of one-way ANOVA. You can also use this one for one-way ANOVA. It's just like the way this one we can use Mann-Whitney U for two independent groups. Also use median. You know, median is not only for two independent groups; it's for 3 independent groups. So the Mann-Whitney Kawali is straightforward for a non-parametric counterpart of one-way ANOVA. This one also can be used. So this one is like it's spread above on 2 or more, whereas Ukawali is for 3 or more. Just like ANOVA is for 3 or more. I don't know if you get it now.
Sir, you are confusing me, because one thing I know is that ANOVA is parametric.
I know, we know now. ANOVA is, I say this is also a non-parametric counterpart of ANOVA. When I say non-parametric counterpart, that shows that ANOVA is parametric. But this also is Ukawali is a non-parametric counterpart of ANOVA. This one also is a non-parametric counterpart of ANOVA. That's what I'm saying. But mute yourself, you are disturbing on your machine.
Okay, thank you, sir.
Prof, are you okay? Are you satisfied with that?
Yes, I'm okay, sir. Yes, I do.
Please, so my question is, so that means that table at the lower left corner is what we now use to run the chi-square.
Exactly.
After we split it.
Exactly.
Okay.
Exactly.
So does that mean, so that means we have to do this manually, then now bring it out like this, then put it
run it. I will show you the way you run it now. We are going to demonstrate it.
Oh, I see. Okay.
It's so funny that you are not going to use the normal chi-square where you go to cross tabulation. So if you do cross tabulation, so give you the same, but you know, you can, because your data, the way it is entered, say you are listening to me now.
Yes, sir.
You listening? You know the data is not categorical. Yes, I'm now. It's not the original data. The way you enter into computer is not categorical.
What?
If you are solving it with time, you have to first of all categorize like better. They have already made the provision also for you to run in the SPSS and give you the same result as if it's categorical.
Oh wow.
You get it now. So that's just the logic behind it. You know, if you look at all these things, the people that are doing program also, they will get, you know, they are business people. They will employ experts when some of the clients say we want to be able to do this with it. They will bring experts, statistician that will say this is the logic. So the programmer also will now work together with the expert and that's okay, this is the formula, this is the logic behind it. Okay, let them put it as a program, and they will do it. That's just it. I don't know. Should we proceed now?
Yes, sir.
Sorry, I don't know whether I can see this. Dr. Dolapo.
Yes, sir.
Thank you. I appreciate this. I think it was a cause of an argument between me and somebody. We were actually looking through a manuscript.
Okay.
And the person, instead of like, he was trying to compare two groups and survivors and non-survivor for a particular treatment.
Yeah.
And he now decided to calculate the median test and was saying it was not significant. I said, well, to me, it's not appropriate. So, because I think it's like a misinterpretation of statistics.
Yes. If the outcome is already survivor and not survivor, is categorical.
Exactly.
And how can you use this thing? How can you use? You cannot use median test. No, it's not possible.
I don't know what he calculated there, that he was putting the significance and the p-value is less than 0.5. Probably it was.
Maybe he ran the normal distribution and it was skewed, so he decided to use.
No, the issue there is that
why am I saying this now? If you have two groups and they are skewed, and you want to compare them at the baseline, are you going to use the median test or you are going to use the mean? That is the issue. I think that's what is confusing now.
You see the issue here. The issue here is when you have you are comparing two groups, it's skewed.
Yes.
You opt for non-parametric. You can decide to use median or use Man Whitney U. There's nothing that put you in a jacket to use median. You get it? You just to compare. And that is when you say median, that's where I'm even having issue. From what we just did now, did you in this one, are we comparing median? We're not comparing median. Do you get vision now? So probably some people just come and say that non-parametric is a comparison of median because they hear the word median. And even this median is not as powerful. People prefer people that know what they do. They will prefer Man Whitney U because this Man Whitney is more powerful than this. If you look at it, the Man Whitney U and the Wilkinson, number one, they look at the direction, the sign. They also not the sign. They rank it. And they also sum it. But this one just use the median to dichotomize. That's all. They just use the median, the pool median for they combine the two. They now look at the median, overall median, to divide them into two 2x2 table. If it is you are dealing with three category now, where we are talking of for non-parametric components of counterpart of ANOVA now, we are using median as non-parametric counterpart of ANOVA. It will give you 2x3 table here. If you are having 4 independent groups, it will give you 2x8 table. They can use the median to divide each of the group into 2. The one that are more than the median, and one that are lower than the median. And now try to see do you get the picture? So they just use the median to. So they are not actually comparing median, though median is used to dichotomize it. So for me, I will go for Man Whitney U. If you go for this one, it also is not bad. But let me tell you, either your DC, if you feel that your DC is skewed, you quote the mean plus or minus standard deviation and the median. That's the essence of quoting the median to support the mean. Not that you discard the mean. You quote the mean, the standard deviation, and the median. You get it? But if something is well normally distributed, that shows that the mean, median, and mode are almost the same. There's no point repeating, say, you are quoting the mean and quoting the median, because when something is normally distributed, the mean, mode, and median are the same. So when you quote the mean represents all of them. But when it is skewed, the mean, mode, and median are not the same. So you should quote the mean and also quote the median. Does it make sense now? It's not as maybe if something is not normally distributed, you discard the mean, you are now running with the median. No.
Okay, you actually just answered the question I had, because I was about to say that the reason why people, I think the media was not for the inferential, it was for the descriptive. You know that initial one where, like, when people run it and it's like maybe it's skewed. Exactly. You know, when you're initially tabulating your age. So because what happens is that because it's skewed, people will not like, so they think that is about the median, but, it's for the median is for the descriptive part, not for the inferential part.
Okay, go on.
You answered the question. If I answer the question that has been, because I was like, because I know that they might ask me that why did I put in both the mean and the median. And it makes so much sense because when something is not normally distributed, it's still okay to put the mean, the median, and because they will not be.
They are not the same.
That is, it will not be equal. So, if I'm asked.
So if that's the way you answer them. If something is normally distributed, you expect the mean, median, mean not to be different too much. So there's no point quoting. So mean is standing for all of them. But when there is skew, the mean and median will be different. So you cannot say because they are skewed, you now discard the mean and now quote the median. You discard it when you quote the two of them. He give you the picture the way it is. He give you the total picture. You see quote both of them.
Yes.
Standard deviation. So even the test you are doing, people say they are comparing media. Where are they comparing media? Is there any of the tests we have done that are comparing media here? There's not. Even though they call it median test, it doesn't compare media. So that is just the logic. You know, sometimes.
Hello, sir.
Yes, sir.
Hello, sir.
Welcome, sir.
Please, sir, can you give us one of these days? Give us an example like this. One of these, maybe like this median test, the one that has, let's say, 3 categories.
When we are doing ANOVA, you know, it's supposed to be next week where we were shifted to another week because next week we want to still do how to run SPSS, how to use SPSS next week. After that one, we do ANOVA. It's going to be ANOVA and the non-parametric counterpart. In that case, now you are talking of 3 or 4 groups and the non-parametric. So this one will come in because it's a non-parametric counterpart of ANOVA also. Because its group is for 2 or more groups. I don't know if you understand me now. So Kukawalis will come in, median test will still come in also. You understand me, sir?
All right.
In that case, instead of giving you 2 by 2 table for chi-square, it will give you 2 by 3 table or 2 by 4 table. That's only the difference. You see, calculate the chi-square just with the degree of freedom may give you whatever. Like chi-square, in fact, here now by the time you divide it with the median, it has come down to chi-square. There is only that the computer has made such a way that you use your data the way it is. You don't need to be grouping it. This one is just for our own explanation. As we run it now, you're going to see the way it comes out. You understand? You're going to see the way it comes out as we run it. And if you go and check now, use Stacker, or I can even use this thing. I will still put in my slides. I will use AND to put inside before I share with you. If I decide to use this, okay, let me use what do I call it? WinPepi to compute this thing. And before we run it, you get the same result. You get the same result. So that just, I don't know if there's any other explanation concerning this issue. Okay.
Okay, thank you, sir. I think I understand.
Welcome, sir. Yes, sir. Okay. I want to do something. So, can you see WinPepi? I put WinPepi. Can you see? I share it. Can you see it? Can you see WinPepi?
Yes.
Yes, sir. Yes.
I share WinPepi now, yes. So,
yes, sir.
Yes.
It's off now.
Please, sir, can you send us this WinPepi?
Okay, I think I will mail it to some people. I will mail it to you. I will share it with you. I will share it.
Please.
I will share you some my people I've just sent to you. So now let's look at it. The other one 8, 12, 12.
It's not showing now.
It's not showing.
It's showing now. It's showing now.
Showing.
It is showing now.
Yes. I just want to run that thing. So before we go and run it, you will see. You will see the.
It's showing now.
Can you see the Pearson chi-square is 1.600?
Yes, sir.
1.600.
Yes, sir.
You will see yet corrected is 0.9, right? You see chi-square is 1.600. The p-value is 0.206, yes. Right? And yet corrected chi-square is 0.900. And the p-value for the yet corrected is 0.343. Is that all? Can you see it on the screen?
Yes.
Yes. So let's go and run the. Let's go and run now. Let's go and run the thing. Let me quickly bring it out. So let me share the, so this is the, look at it. You know, if you look at it, the account type, current, then savings, because it's independent, so they are in series. I think I keep on emphasizing this. Whenever you are dealing with independent group, when you finish entering one, you continue with the other one. No? Unlike the other one that is pair, you remember the depression, Sunday and Wednesday. They are in front, separate column, right? Because it's pair, is in parallel. Whereas the drug and alcohol substance use, they are in series because they are independent. So the same thing with this current and savings account, they are in series because they are independent group. So let's just go straight. So analyze non-parametric. So now instead of saying two independent sample, you now say K independent sample. Can you see now? Professor Dokidem, you know, we are dealing with two, but because this median test is actually for two or more, so you cannot pin it down to only two. So you now say K independent sample, it can be more than two, can be three, can be four, can be five sample. Now K independent sample. So when you put in now, the satisfaction is your variable. The group variable is your account type. You now move it there. It will now, instead of you, it now say give you range, define range. That is minimum. Instead of say 1 and 2, because it can be 3, it can be 4. Now say define range, minimum and maximum. Our own minimum and maximum is 1 and 2 because there are two groups. We have coded one to be 1, the other one to be 2. If there are 3 groups now, the one we're going to do when we do ANOVA now, you're going to have 3 or 4. You can say minimum 1, maximum will be 3 or 4, depending on which data you are dealing with. When you do that, if you look at it, can you see Kuka-Wallis is here by nature? You put it there. The median, if you want to, you could put median. Even if you calculate Kuka-Wallis, that is useless because Kuka-Wallis is actually for 3 groups or more. Yes, you can uncheck or leave it. But it's the median you are interested in. When you just run it. Let me share the output. Can you see the output now?
Not yet. Yeah.
Not yet.
Now.
Yes.
Okay.
Yes.
Can you see? You put the table there, 8, 12, 8, 12, 8. Can you see? Can you see the chi-square? Chi-square, Pearson chi-square 1.600. Look at the p-value 0.2206, what we calculated with the other one. Look at year corrected, 0.9, and p-value. Can you see? It's exactly what you get if you are running with SPS with chi-square, because they have already programmed it also. Through this avenue, you can go and run the same thing. So that's just it.
Listen, there is chi-square there in that non-parametric. Can we just use it and see what will happen?
Well, let me see. Okay, let's go there. You know, okay. Non-parametric, legacy, this one.
Yeah, good.
Okay. Satisfaction. Okay, this one was the one we used for, don't worry. This one we use for goodness of fit. You remember? Okay. Prof, were you around? Okay, you were. Prof, were you around for the training on the chi-square and this thing?
Yes.
Okay, you are around now. You are around for the chi-square now. For all those odd ratio stuff.
Yes.
You remember, this is where if you want to do goodness of it, this is what we use. In that case, when you move it here, you now come and put the value of the who is making something is making up. You know the for goodness of it, maybe we use block group there. what are the frequency? We first of all calculate the expected frequency, the expected frequency in the population. We now list them there and now run it. So this was especially made for that case. It's not for this case.
Okay.
Yeah.
Okay. Thank you.
You know, the issue there is that, just like what I said, the people that do this something, look at them, you are having, if they have not out of version 27 now. So they have, from the time they started SPSS, they have made improvement. It's not at the beginning, not all these things are captured. So when the user begin to suggest this, they begin to make, how can we incorporate it? So sometimes it may not be as straightforward as you expect. They just look for a place to incorporate those things. That's what is happening. So you remember anything that is that involves cross tabulation, that's where you go under cross tabulation. But when it comes to measure of goodness of fit, because measure of goodness is not about cross tabulation, it's only one group. You're just comparing with, so it cannot work. That is why you put it there. And all these other one we are doing also, median tests, all those, so they are not, it's not under cross tabulation directly. So that is why they just do it like that. So I don't know if there's any question concerning this. So this is a matter of we try to practice and practice and practice and practice. Read and practice and read and practice. That is where it sticks. New reading. What I would do is that I work more on the slide before I share with you some of all those issues. I will incorporate them so that when you are going through the slide, even screenshot I put in on the slide so that you still remember this is what we do, this is what we do. I will do that. And even those that Prof was raising, Professor Wakwe was raising, those is there something I will try to see, I'll put it there. So that the slide will be rich. Yeah, we just have it. So I think everything will be okay. I don't know if there's any query or any other question. So that we'll quickly review what we have done. Any question? Any other gray area? Any other question?
Thank you very much, sir. It was really, it was very, very good. Thank you.
Yes, this is what we plan to look at ab initio, T distribution. T distributions. Okay, let me just stop the recording because so that I don't increase the volume.